Okay, today's lesson is going to be on algebraic fractions. And the first thing we're going to do is simplifying algebraic fractions. We can simplify algebraic fractions by looking for common factors in the numerator and the denominator. Sometimes we might have to factorise a quadratic if the numerator or the denominator are quadratics. The first example we're going to do is this one. This doesn't have any quadratics in it, so we're just going to look for common factors. So looking at this example, we've got 3 times x squared times y to the 4 over 21, which is 3 times 7, times by x times by y to the 5. Now, often what people will do is they'll have a look at the numerator and the denominator and they'll cross out terms that match. So we end up with, on the top we've just got this x left, and on the bottom we've got 7y. It's fine to do that as long as you understand why we can do that, and as long as you understand that it only works for multiplication. So if I get rid of this answer, go back to none of them being crossed out, what's actually happening, the reason that we can do what we just did, is if we take out the common denominators, common factors, we've got 3 in both, we've got an x in both, and we've got 1, 2, 3, 4, 1, 2, 3, 4, we've got y to the 4 in both, and we can separate a fraction into different fractions multiplied together as long as the top and the bottom are all multiplied together. So if we do 3 times x times y to the 4, we will end up with 3 times x times y to the 4, and then we've got this additional x on the top here that doesn't pair up with anything at the bottom. Same for the denominators, we've got 3 x and y to the 4. So then in the denominator we're left with 7y. So it's absolutely fine to split those fractions up, but then the reason that we can start doing crossing out like this is this 3 over 3 is really 1. And this x over x is really 1. And this y to the 4 over y to the 4 is really 1. So what we end up with is 1 times 1 times 1 times x over 7y. So we've just got x over 7y. You don't need to write it out like this at all. I'm just showing you why it works. It works because the different parts of the fraction turn into 1. When you divide something by itself, you end up with 1. So we're left with x over 7y. If we had something like this, you cannot split that fraction. So you cannot do that. You cannot cross out the x's and say that equals 3 over 7. That would be completely wrong. It only works when we're multiplying. So what I would like you to do now, please, is pause the video have a go at questions 1 and 2 from exercise 1. They are like this example. And then we're going to go through another example. So I am going to show you the answer to question 1e. So for question 1e, we've got 26 a squared b cubed c. And then I'm going to turn that 52 into 26 times 2 b to the 5 c. And you don't need to write it all split out like I did up here. The 26 over 26, because everything is multiplied in the denominator and everything is multiplied in the numerator, the 26 over 26 cancels. The b cubed will cancel with this b to the 5 is really b cubed times b squared. So we'll be left with b squared there, and the c will cancel with the c. So we end up with a squared in the numerator over 2b squared in the denominator. Except what have I done wrong, everyone? I've missed off the c to the 4 at the end, haven't I? So that would actually be a c to the 4 there, which means this bit will go, this bit will turn into a 3. So correcting my own answer, I'll have a squared c cubed over 2b squared. There we go. I'm also going to run through a couple of the questions from question 2. So for part A, 7x over 5x minus x squared. You can factorise x out of the numerator and the denominator. So then that x over x equals 1. So you've got 7 over 5 minus x. Then if we have a look at part E, there's not a lot of factorising you can do here. We can take 4 out of the numerator, and we can take 4 out of the denominator, and that's all that's going to cancel as far as I can see. So you end up with 3 over a squared b cubed plus 2a to the 7 b to the 9. I have put the answers up for these ones, so mark your answers, and if there is one that you are not sure how to do or you get stuck on, leave me a comment and I will go through it. Another example on simplifying algebraic fractions is where we have quadratics in the numerator and or the denominator. So for this one, what we want to do first is we want to factorise these quadratics to see if they have any factors in common. So the top can be factorised into x minus 4, x plus 4, because it's a difference of 2 squares. And the denominator can be factorised into x plus 4, x plus 4. The x plus 4 in the top will make 1 with the one of the x plus 4s in the denominator. So we end up with this as our simplified fraction. Now, as I said before, you cannot then do this because you can't separate the fraction out. So this is your final answer. So I would now like you to have a go at questions 3 and 4 from exercise 1, please. I will go through a couple of answers and then we're going to go on to adding and subtracting algebraic fractions. The first one I'm going to go through is question 3e. So we can factorise ab out of both the numerator and the denominator. So the AB over AB makes 1, and we're left with 3A plus 5B over 7B squared. Next one, for 4C, we need to factorise the numerator and the denominator. So the top factorises into x plus 5 into x plus 2. The denominator is going to factorise into x plus 5 into x minus 3. Now, when we're doing this type of question, if you've factorised the numerator first, have a look if either of those factors work for the denominator, and the other way around, if you've factorised the denominator first, have a look if any of those factors work for the numerator, because usually in this type of question there are going to be matching ones so that they can make 1 and cancel out. So x plus 5 over x plus 5 is 1, so that cancels, so we end up with x plus 2 over x minus 3. Going on now then to adding and subtracting algebraic fractions. We take the same approach as when we add or subtract numeric fractions. We need to put them over a common denominator. So we'll do this one as an example. If we want to express these fractions as a single fraction, we need to put them over a common denominator. The obvious denominator to use is 12. So we're going to multiply the first one by 4 and the second one by 3. So they're now both over 12. I'm going to put this all over one denominator because they've got the same denominators, and I'm going to multiply out the brackets. And that is my final answer for that one. So, could you please now have a go at questions 1 and 2 from exercise 2? Once you've had a go at those, mark your answers from the answers that I've put on Show My Homework. If there are any that you're not sure on, let me know and I can do a video for those specific examples. But for now, we're going to move on to another example, which is slightly trickier because the denominator is not just a number, it is an expression. So we want to express these two fractions as a single fraction. It is still going to be exactly the same concept. We're going to put them over a common denominator. The common denominator we want to put them over is x plus 1 into x minus 2. That means we need to multiply this first fraction by x minus 2, both in the numerator and the denominator. We need to multiply this second fraction by x plus 1, both in the numerator and the denominator. What I'm going to do here is I'm going to keep the brackets for now, so that when I put them over a single denominator, I don't lose this negative sign somehow. The next thing I'm going to do is I'm going to multiply out the numerator because some terms on the top should cancel. but I'm not going to bother multiplying out the denominator, as it doesn't make it any neater. So simplify the numerator by collecting like terms. And can you spot the mistake I've made? This one should be a 3. So always check your working. So I've got -3 there, so actually this will be -1, not +1. Last example is this one. Again, we are expressing them as a single fraction, but what we want to notice in this one is that we have a quadratic here. Now, if we took the same approach as in the previous questions, we would do this. We would say that we want to add them together. So what we need to do is multiply the first one by x plus 2. And we need to multiply the second one by x squared plus 3x plus 2. That looks absolutely disgusting, and it is, and it's unnecessary. So I'm going to get rid of that for a moment. Because what we should notice is that this quadratic can factorise. And if we factorise that quadratic, we'll find that it already has a factor in common with the denominator of the second fraction. So actually, we don't need to multiply the first fraction by anything. We just need to multiply the second fraction by x plus 1. And then they have the common denominator of x plus 2 into x plus 1. And we can put that all over one denominator. Then let's multiply out the numerator. And now let's simplify the top, so we'll get x squared plus x minus 1 all over x plus 2 into x plus 1. And that should be everything you need to have a go at the remaining questions. So can you make sure you've done all of the questions and marked them, please, and then upload that to Show My Homework. Once again, if there are any questions that you get stuck on and you want me to go through the answer, please let me know on Show My Homework, and I can either go through it in our next lesson or I can record a video for that particular question.